Swayam Prabha. Digital India. Educated India.
Sir, start, sir.
Okay. Okay, let us wait for a few minutes and then we will start discussing some of the doubts they have already asked in our forum. Okay, so let us discuss the questions that was posted in the forum. We have six odd questions. most of the questions, including these questions, are already been answered in the forum. But still, those questions has some potential. If somebody already, sometimes you may have missed that one, or maybe sometimes that may help you in the future. The first one is, it was from lecture number 4, very early lecture, the first week itself. It is about the support and the reactions. So it was asked that mathematically it was appeared that a cantilever structure with one end hinge and one end roller support with the internal hinge in between is stable. But it is appeared that its structure is bent because of the internal hinge. So if the vertical force is applied on them, see, it is appeared like that. Definitely, it is depend upon some other things also. If you consider the mathematically, you have already written that it's mathematically it is stable. It doesn't have any instability. It has 3 plus 1, I think 2 plus 1, 3 unknowns, and there are 2 equations from static, sigma Fy equal to 0 and sigma moment equal to 0, and one additional equation from the hinge. In the hinge, the moment is 0, so number of equations are equal to the number of unknowns, so it is stable, statically determinate. But it appears, yes, it appears that if we push it and then the slide, it may slide. So there are some assumptions over there. Assumptions was, if the roller is on a very smooth surface, very smooth, almost frictionless, then probably it could happen. I mean, there is, but to run the roller, you need a horizontal push. Without the horizontal push, it cannot be. Right, and it is also depend upon the rigidity of the member. Suppose the member, cantilever member, is not so rigid, so itself it may bend down because of the non-rigidity of the member. But as you know, we have discussed that the engineering mechanics, we deal with the rigid bodies, so we do not allow any kind of deformation and all. It's only the force, the equilibrium and moment equilibrium. So as if you look like this black color portion of the cantilever beam is very rigid, then there is no question of this yellow color hinge to be deep down. And if there is no dipping down of the yellow color hinge, there will be no push from the horizontal side, because there is no horizontal force given in the figure. So if there is no horizontal force, the roller cannot move. And if roller cannot move and the pin joint or the hinge joint cannot go downward or deep downward, the structure is stable. So mathematically it is stable, and also based on the assumptions that the bodies are rigid, not going to deformed, and the hinge is the roller or hinge, which has some kind of a friction. Even there is no friction or very less friction, you need a horizontal push to move that particular roller in. So there are some questions. Good. Okay. The difference between the reaction, restraint, and constraints are let us go one by one. The reactions are the force that provided by the supports or the different type of the connection or different type of the internal conditions or different type of overlapping with each other, the beam or maybe any kind of 2-3 members of same element. There may not be any support, there may be a connection or the overlapping. So the force that has been reacted back to the particular system, that is the reaction. This may be a force, that may be a moment, that is the reaction. The restraints are some of the condition of the supports are such a way that it will not allow any kind of rotation or deflection. So rotation or deflection is the fallback of the total system under kind of a load. Okay, suppose if there is the cantilevered beam, and if you put some load, definitely there will be some kind of deflection at the free end, right? So if you just put a kind of a roller support or any support at the free end, it will restrain that particular deflection. Okay, it will allow some rotation, but it will restrain some amount of the deflection. Instead of the roller support or the fixed support, the hinge support, if you provide a fixed support, it will restrain both rotation and the deflection. It will not allow. So some typical condition or some typical nature or character of the support, which will give you some kind of a restrained behavior, and as and when it gives some kind of a restraint in deflection or in the rotation, it will automatically provide some reaction. Again, if I go back to the same example, if it is a cantilever beam with free end is freely hanging, no restraint, no reaction at the free end. If you put a roller support, it will have restraint in the deflection in the y-axis or the vertical axis. So it will give you a reaction in the y-axis or the RV, the reaction at V, vertical axis. If you put a fixed support, it will not give you any kind of deflection. Also, it will not give you any kind of rotation. So those are the restraint, and the reaction will be two. You will have the vertical reaction. You will have a horizontal reaction also, because it is not going to allow you any kind of horizontal movement, and also it will be not allow any kind of rotation. So there will be moment will be generated. Now last one is the constraint. Constraint is not related to this. Constraint are, there are some condition which I may apply in some cases, in some case of the structure. The constraint are, suppose at particular section of a beam, the stress should not be this more than this. Okay, so total, suppose I allow some kind of a deflection at the middle, the mid span. Suppose it is a cantilever. Okay, let us again assume a cantilever beam. No support at the free end. It is a simple cantilever beam. So under the load, it will be able to deflect. So I will allow deflection, but constraint is the deflection will be limited to 1 inch. I will not allow more than that. Okay, I am not going to fully resist that, but I will not allow that. So there are some codal provisions are there. Suppose you are designing a beam, simply supported beam. So there are some limited amount of deflection is allowed. So that is the constraint. So the reaction, restraint, and the constraint. So let me go to the next question. How to analyze and design shell structure? Okay, software that are used for analyze the cell structure, analysis of the shell structure. Basic skill sets are that are required for the analysis of shell structure and folded plate structure. There are many softwares. Now the thing is that this is very interesting question, of course. You have to actually choose the software that how much detailed analysis you want. See, if you are a civil engineer or if you are an architect, I believe you are going to design a shell structure which is concrete shell, large scale, and it is a large shell structure. And then it may be two type of shell or plate structure. There are two types. One is called the thin shell and one is called the thick shell. The thin and thick shell structure is depend upon the aspect ratio of its thickness of the shell or the plate, and the other dimension is the span or the larger dimension of the any one of the larger dimension. Sometimes maybe there are two dimensions, x-axis and y-axis, both may not be equal. So based on that, it is thin or thick shell, and the behavior, the mathematical derivations and everything will differ from the thin and thick shell point of view. So the softwares like structural softwares like ETAB and the very popular one, right? The popular one is I will tell you that those softwares, which is very much popular in the civil engineering domain, can handle the thick and thin shell structure, but it in limited form. Limited form in the sense, if you want to go into detail of stress in each and every point, you won't get it. Or if you want to get it, it will be convention. I mean, you have to actually go into split and all. So that is not going to be done. And that will, more or less, that will be helpful for our purpose, because we have a factor of safety. We need to know that some typical deflection, typical stress in the midsection or some of the typical section, and the reactions, horizontal reactions, push pull in the in your the support in the ring beam and all. We can find out that. Yes, Stat Pro. Praveen, you are right, Stat Pro. Thank you very much. So that will give you a limited shot of kind of a this thing. But if you want to do the actual analysis of the shell, which is a thin shell, and suppose it is the aerodynamic behavior, suppose you want to find out what will be the stresses in the shell in aeroplane, or maybe any rocket launching, when the rocket is launching or whatever. You see, the rocket is a cylindrical shell. The shell of the surface of an aeroplane is also a shell. So in that case, this is under a huge pressure, I mean huge load of wind, draft force also. So in that point of view, we have to do the finite element analysis. You have to do the finite element analysis in the ANSYS and some others, the popular software, where you can actually do the real analysis of the shell, thin shell, which is under typical type of loading. See, when the rocket launches, because of the density of the air changes in various times, the typical forces applied on the surface of the cell, it will be different. So from that, you have to take care of that. Then another question: how membrane stress is different from the similar bending stress or the shear stress on the axial stress? See, the bending stresses are actually, see, what are the names suggested? You have written two correct way. I mean, one is shear stress, one is axial stress. These two are the fundamental stress. Okay, because of from the body point of view. Suppose if you take a body, if you take take a pencil. So if you pull the pencil, it is axial, or push, so compression or the tension is axial. And if you want to chop off with a knife, something like that, cut the pencil into the pieces, so then it is a shear, right? But bending stress, membrane stress, those stresses are due to the action of the thing, okay, the member. So you put a member based on some kind of the horizontal support, put the load perpendicular to that, you will get bending. And same, suppose you want to make some kind of a torsion on the axis, you will get a torsion. Torsion gives you a shear stress. So torsional stress is, yes, it is name suggests, because of the torsion I have embedded some kind of a stress, which is torsional stress, some kind of a member and the support, some kind of force. I have embedded a bending, and due to that there is a bending stress, and due to the profile of my the element, and due to the support condition, it is a membrane kind of a thing. It is very thin, and it is a membrane stress, like a balloon kind of a thing. But finally, it will boil down to your axial stress, compressive, tensile, or shear. Okay, as you see the bending stress in a beam, what happened? Due to the bending, the topmost fibers and the fibers above the neutral axis is the under compression. Of course, if it is a case of a simply supported beam, and the layers which is below the neutral axis will be under the tensile stress. Okay, fundamentally they are axial stress, tensile. Each layer are under tension. It is maybe a higher tension in the lowest zone, a deepest zone, and the lower tension near to the neutral axis. Similarly, the upper portion has a compressive stress, which is axial, but it is actually bending due to the bending. Okay, that is why we call it as a bending stress. Is a phenomena is a bending, but finally it is axial stress. Similarly, torsional. If you give the torsion, it will give you a pure shear stress. No bend, axial stress will come. Right. So one layer will try to slide over other. Now, suppose you take a onion, make a two piece of onion, one circular onion you take, and just make it two pieces, and you try to put a torsional force at the center. So what will happen? The layers of onion, there will be 5, 6, 7, 8 layers, will try to slide over each another. Okay, and as and when it is crosses the limits, it will just disintegrate. So that is a shear stress. So because of the torsional behavior is the torsional stress actually embodied the shear stress. Similarly, the membrane stress also. Membrane stress are because of balloon action or this kind of a stretching, and it will be actually showing some kind of a compressive stress in the top part and the tensile stress in the bottom part also. Yes, this StatPro and the ETFs are used for the moment resisting frame, but you can also design. I'm not very sure, but how critically you can design the curvilinear members, curvilinear profile also, curvilinear plate shells also. But it's how much detail I do not know. I'm not working in it. I have worked with the StatPro with this moment resisting frame. You're right, but those are now available with some. May not be very much detailed, but for regular kind of a shell structure, like a barrel vault or maybe a dome. Because you see, I have seen somebody actually using StatPro or maybe that something out of these two, designing the water tank, RCC water tank, which is actually a dome. You know, the dome structure and the cylindrical fascia. So there may be some kind of the assumptions are there. There maybe you have to find out some strip loading and all, and then you have to find out the things symmetrically, kind of a thing, and very symmetrical order things you can actually do. But definitely not in very much of detail. How much detail you can do and what is the present version of the StatPro and that how much give you the facilities, I'm sorry, I do not have that idea. Basically, we are architects. We whatever complicated things comes, we discuss with our structural colleagues, and we provide them the opportunity to design those. Good. If you have some other queries, please continue. Okay, there are some questions in the Google form. Okay, let me check. Alisha, I cannot actually read that. I have opened the Google form, but there are two questions from Mr. Praveen. which I cannot actually increase the size of the window. I don't know how to do that. I use something like a lock. Can you just cut and paste it in the or live YouTube live? Then I can answer. I am not able to do it. Thank you. Okay, now I think. Okay. I think this is the first question. So this is a question from the tributary area. I will come back to that. I mean, let me first answer some questions from our forum, not forum, sorry, the Google Doc. So there is a triangular slab. Somebody, Praveen, has been asked that there is what is the tributary area for the triangular slab if a balcony is formed from a right angle triangle with the walls and beams in right angle side. Do we require a beam in the hypotenuse too? I'm not very much clear with this question. Kind of a sketch could have been helped me. I will just say that if you go for any kind of irregular kind of a structure, I mean, kind of a structure or balcony, whatever, maybe a cutout, whatever, it is better to give the boundary edges with a beam. So in that sense, as I have actually read your, understand your this thing, I will definitely require a beam in the hypotenuse side. But the question is not very much clear to me. And what would be the tributary area? Tributary area in that case will be the, in case of a triangle also, we will be making some kind of a geometrical proportionate the divisions. And from that we can calculate, and there will be some kind of overlapping because it is not a very regular kind of a grid of square or rectangular grid. So if there are angles, there are some kind of overlapping. So overlapping also will calculate, and there will be some additional load in the both the sides. And that will be in the safer side in that case. So now let me answer the another fellow or somebody. He is a civil engineering students. Civil engineering students, can you explain the role of an architect? Okay. Okay. You are a student. Can you write? You are a student or you are a civil engineer? Can you just write down? And I'll answer. Definitely, I'll answer it. I'd love to answer this question, but let me. You write down. You are a student or already a graduate engineer. Okay. Another same person, Praveen, has also asked that. Let me copy it over here. StatPro. This is also answered in the StatPro. What structural software would you suggest to architect to perform best level of the structural analysis for small scale residence? It is StatPro. There are two reasons. Number one, StatPro is very popular software. Most of the engineers in our country use this particular software for all type of design. So if you are in some problem in some days, you can actually talk to your structural counterpart and then they can help you. That is number one. Number two, suppose in some cases, of course, it will not applicable for the residential building. because your client may not be look for that. But if it is a kind of a little bit of the government project, or maybe a kind of the high quality project, maybe private projects also, even if you employ a structural engineer from your firm, that particular structural calculations need to be validated by some third party. Third party validation is required. So for the third party validation, it is better to deal with ETABS, or maybe the the StatPro, those software which is popular software. Suppose you have run some some I mean your the self-made program, or maybe some software which is available very cheap, and or maybe some cracked version, very cheap version somebody has developed. It may be good. I'm not saying that that is not good, that is not unsafe or whatever. It may give you excellent result, whatever, but that is a kind of a standard things people will ask. Okay, and you should also have some kind of a confidence that whatever I have done, that will actually yield a good result. It is a proven software and all. So and this StatPro is very easy to understand if you just have a basic knowledge of the structural engineering or structural things, which actually architects are also taught in various schools. It's enough to at least start with that, and as and when you get the interest, you will get to know that. You are writing again. I have not written, so let us assume that you are a civil engineering student, and I have to let me explain the role of an architect. So any project, if you take any kind of a project, built environment project, see, the client is actually going to give the project to a particular party, particular person who is going to design the particular his built environment. Suppose if it is a mall, if it is a hospital, if it is the airport, Airport Authority of India. In case of a hospital, it may be a private body, maybe a government. So anybody of that kind of a thing, nature will try to, give the particular project to some person. But a particular building has to be constructed with the help of a lot of people. The architect will design the building planning and all, the beautification, the rules, regulations, and everything, the bylaws, development act, everything he should know. And then he actually involved in the specification of the materials, the other the space distribution, and suppose day lighting, lot of things he will take care. But after this everything is satisfied, it need to go to the structural engineer for the structural design and vetting. So it may suppose if an architect is his job is done, then the client need to take that file, that drawing sheets, everything to structural engineer. After structural engineer done his job, then the client need to go to that air condition engineer or something like that, one after another. So it is a bothering to the client. So what the practice is, a particular project was given to an architect who is the responsible for whole. So he'll take the money, he will take some 2%, 3%, whatever, and then he will take the whole responsibility of the design. It includes the architectural design, it includes the structural design from the civil engineer, or structural engineer, it includes the foundation design if there is a complicated case, it includes the electrical layouts, it includes the HVAC, the ventilation, that all the ACs and all. Sometimes if it is the auditoriums and all, it is include the acoustics. So everything, it is his responsibility now. Now whatever fees has been given to him or her for the fees of an architect, he will get to, he will actually have his own associates. Okay, so he will also distribute and some. So that is the total mechanism, the things. So in a nutshell, the architects will be actually the key holder of the particular project before it starts. After the project has been starts, definitely architect will going to help, because every time there is some problem arises in the site, he has to go, he has to see, he has to change the drawing. Again, he has to consult with his the architect, the structural engineer, his SBS engineer, see there is some problem, so you change the drawing. So he will definitely there also in the time of construction. But in that construction stage, maybe some the PMC, the project management consultant, maybe take a lead role. But in time of design, the architect will take the lead role, and that will take care of the things. So basically, a structural engineer will, for building project, will work under an architect mostly. And for some other project, bridge or maybe some kind of transmission tower lines, maybe some tall chimneys and all those kind of things, the structural engineer is solo dependent on that. Thank you, Praveen. So I think I have answered both the live session, the questions which was there in our Google Sheet. No, I think there is another question. No, already I have answered that on shell structure. So 3 questions were there in our Google Sheet. So I have answered all the 3. In the live sessions also, it is still on. If you want to ask some question, please ask. We have still some time left. It is 1 hour time today. And we have some other courses also. So at around another 10 minutes, it will be over, 10-15 minutes. So in the meantime, let me tell you something. Please go through the PPTs. There are some portion from lecture number 26 onwards. The transcript is not ready. It will come very soon. Some of the students has already asked for. So it will come. It will definitely come, and our the teaching assistants, they are ready to handle that thing, and they will provide you the notes and all. But there is still 1 month left for your final examination, and for the final examination preparation, you can actually do from our my PPT and the things provided, that the PPT and the lectures. So you just go through the lectures and all. The end semester questions will be based on those only. The very similar way it has been given the assignment and all. Similarly, it will be there. I mean, some multiple choice questions, some the matching from the table 1 and the table 2, group 1, group 2, like that. Some numerical things which you have to calculate and put. So basically, it will be very similar way. It will be there. There will be. I think if you have done well in this assignment, there is no worry that in the end semester will be very some parallel kind of thing, but definitely not the same type of questions or same type of this. But if you just go through the PPTs and all, there it will help you in that. The transcripts and the notes will definitely come within 10-15 days time. There are some questions. Can this discussion can happen on Google Meet or Zoom? That I cannot help you because the NPTEL authority of all IITs has a common decision to put it through the YouTube. That is not probably cannot be done now or this year. So that is not probably cannot be done now. And each subjects, I mean courses, which are 8 week course, has been given 2 live sessions. Just this live session and the one we already have after 4 weeks. Next question is, what is the basic knowledge about the structure of a residence? Structure of a residence, okay, of an architect know before it starts the designing it? Yes, there are few things you should know. That what should be the maximum span length? Maximum span of the beam is in residential building is not much, but sometimes what happened that because of some requirement, you need a hall. You need a hall for, suppose you want to have a what that is called nowadays, that home theater or something like that. You need a hall kind of thing. So basically column free, so there are some kind of restrictions, and as you cannot, I mean the room height is not, may not be very high in case of a residential building, you cannot go. So the deep beam may create some problem. So it is always better to restrict your span maybe around 16 feet. 16 feet is how much? 16 feet is about 5 meters or so. 5 3 is 15, 16 feet. So that is one issue. Another issue is that it will try to locate the columns in some peripheral locations and some internal locations such a way that you can create a very wonderful grid. Okay, I don't say that you have to have the equal amount of the distance between the column to column. No, that may not be required. That will, if you do that, your total the arrangement will look like a very monotonous box or so. But you should have a very equal, I mean the designated grid. That means a beam should actually flush with a beam. If it is happened very near to the support, it may cause some kind of a problem like shear. Okay, if so, you can adjust such a way that this kind of scenario doesn't happen. That means a beam should, if it is want to flush, it should flush maybe near to the midspan also. First of all, let us see that if there is a column required or not. So like that, you have to make a good framing. Maybe 80-90% of the beam end should actually connect to a column. That should be your first criteria. Yeah, there will be 20% of the cases you may not match, or you may not want that point. There may be a column, may not be required, but try to avoid some situation where a beam is actually connected to a another beam very close to the support, very close to the column. Okay, so that you have to readjust and all. And in case of the terrace or whatever, and if you want to go for a sloping roofs and all, you should have some before design, you should have some you should actually start with something like that. The edge there should be a beam. Okay, and suppose you want to go for some cantilever thing, the cantilever thing should not be, I mean it is normal. In case of the residential building, we cannot go with a steel, or we cannot go with the pre-stressed member or so. So it will be limited to 2 meter or something like that. 2 meter is 6 feet, maximum 2 meter or so. If you want to place go more than that, you have to need to rethink about your those criteria and all. Okay, 2 to 2.5 meter maximum you can go. Yes, I understand, Radhesham ji. We understand nowadays, at least after this COVID and this the corona spread out, all the classes we are also taking through the Google Meet. We are doing through a team actually, MS Teams. But this Zoom and those platforms are very good interactive. But it is very, I mean, not in this year. I mean, it's, since last quite a few years, the NPTEL actually they have a kind of a tie-up with the YouTube, and that is why it is. We are still maintaining that. So I am not very. I am also. I know that this communication will be good, but I'm not. I cannot help it in this manner because it is a global decision. Oh, Praveen, you were asking. Yes, we are in the last week. We are a few days more, and after that, 1 month we have a test. So, what you will advise for the next course regarding the structure for architects to do after this one? Maybe you can now think of taking some course from the civil engineering department, RCC design, steel design from our institute, our IIT Kanpur. Professor Nirjar Dhang, he is floating some. I mean, it's a very old course. I mean, it's a very popular course. Every time it is repeating. Professor Nirjar Dhang's course on RCC. I will write down over here, Professor Nirjar. He is now presently HOD Civil Engineering. His course on the RCC structures you can take. He is also the teacher of our architecture students also, RCC structure. They also sometimes refer back to his NPTEL course. You can also, if you are interested to the steel structure and all, you can also think of doing Professor Damodar Maiti's design of steel structure is also available in NPTEL. It's a very popular course. Before that, if you want to do want to make your basic clear on the structural analysis and structural the strength of material, he was our ex HOD civil engineering, and he was the director of CBRI Roorkee once upon a time. Now he is a deputy director of our institute, Professor S.K. Bhattacharya, Sriman Kumar Bhattacharya. He is having wonderful course on strength of materials, and you should actually think of going to those courses, maybe offline also, maybe online also. So those courses are good. And otherwise, you now can go through, probably if you look like, if can it is not available in our NPTEL, but maybe privately you can do some course on the Stat Pro, and those kind of courses you can do, which will be helpful, which will definitely be helpful for you to start with some kind of your consultancy. Your dialogue between the architects and the civil engineer, your structural engineer will be very easy if you have a maybe a 3 weeks course on Stat Pro from any institute or for any kind of private bodies also. Okay, and it is available, software is available, and you can actually think of doing that. Then in future, you being I think probably you are an architect, as you are writing like that. It will be very helpful for you to discuss with the people, and those courses you can also take. Professor Dhang's course RCC, it will be fundamentally you'll be clear about the RCC structure. If you take the Professor Damodar Maiti's course, fundamentally you may be clear with the steel structure, at least first course. Professor Dhang has a bridge engineering course and all, so that is advanced. Professor S.K. Bhattacharya, I don't know that whether this course is running or not. He's a very busy person nowadays, but this his course is available in the YouTube. So you can go through the strength of material course of Professor Bhattacharya. I myself sometimes go through that course. I learn from his lectures and all. Sometimes, I mean, I'm not very regular. Sometimes when I get some free times, I can go through. It will clear you a lot of doubts, lot of things. Yes, the Radheshyamji has also written that there is a course on structure, form, and architecture NPTEL, which is floated by, I think, Professor Sadhu Khan from IIT Roorkee. Yes, Professor Sadhu Khan from IIT Roorkee. I know him. He is a very nice person. I don't know about that course, but definitely that course also you can take. If this course was run last time, maybe next semester it may again run. So I think we are in the verge of the completion of this online or this live session. So if you have any doubt, please ask me. Within few minutes I can answer that one. Or otherwise, I will wish all of you very success in your life and also in your studies, those who are student and those who are just graduate or maybe working as a professional. I wish this course has helped you a bit. May not be a lot, but at least just to start with something like it may help it. And if you have some further queries within upcoming 1 month about our technical assistant team with Alicia and Lina will be ready to help you. And with your doubts and all, you can post in the forum, and we may be a little late. Maybe we may not. I mean, sometimes we may answer within 24 hours. Sometimes may little extra time. So, but we will definitely going to answer you. And wish you all the best for your end semester examination, which will be next, I think next month, mid of next month or so. If you have any more doubt, please, I have 2 minutes probably, and then they will stop it because they have some other interactive sessions line up today. So I think thank you very much. And have a very safe stay back in your home and take care of your families.
Thank you, sir.
Okay. বিবাংশু আমরা শেষ করি।